A warm good evening to all. Good evening. Hello. Am I audible? Hello, guys. Am I audible? I hope so. So,
Yes,
yeah, good evening once again, guys. So, uh, we almost started our machine studies, and especially we just started over with our centralized air conditioning systems, and we hopped over to the ductable split air conditioner, isn't it? And I hope we just discussed the basic concepts of the ductable split air conditioner. So I insisted it has to be about the whole connections, which means especially the indoor units and the other study, the mouth study, and similarly the indoor unit study, and typically some kind of certain notes regarding the direction of both indoor units and outdoor units. And especially we studied about the different kind of outdoor units that are actually available on the markets. Later, we studied about the piping, isn't it? Which means, you know, for the load controlling, you must be going with some kind of double circuits. For a typical application, it should be a single circuit. All right. So later, we just discussed about the brochure study, isn't it? According to the available lineups, product line or machine lineups of Blue Star. And I hope I just explained about the number of ODUs, compressors in each different machines, isn't it? Fine. Later, this is how an DSA should work. Okay. So, fair enough. I just explained in the previous session itself. First of all, ductable split air conditioner, which symbolically means an ceiling suspended unit, isn't it? Which is it? It is a ceiling suspended unit. So the connections are still same as per the concealed AC itself. That means you'll be having some kind of threaded rod connections and double nut with locking washers. And typically on the true ceiling, you should be drilled up some kind of anchor fasteners. And these threaded rod are connected along with the anchor fastener and then to the box body of the machine. That means the indoor unit, isn't it? And, you know, we need to deliver this cold air to each and every rooms. I told you DSA, which means symbolically it's not meant to be applied for a single room. Instead of that, it can cover a huge area, isn't it? So that's why here we need to deliver the cold air across the rooms wherever you requiring the cold air. So typically, in order to deliver that cold air, you must need to use some kind of passageway, which is termed as to be the duct connection. So these duct connections are terminated to some kind of air terminals, and these air terminals which will be placed on the ceiling of those rooms itself, especially on the fall ceiling. That's why here you can see some kind of blue color and a red color, like on an orange color. Blue color, which means the air terminal, which is connected along with the duct system, and the orange color, which is installed right on the fall ceiling itself. And these return air terminals. So this orange color meant to be the return air terminal, and it's not subjected or it's not connected to any kind of duct. That means the existing return air or the existing air which having hot and humid conditions or hot and humid characteristics should be enters into the plenum area. All right. So that's how you collect the return air from each and every rooms. And later, you will terminate the return air at the backside of the machine itself. So we studied that on the indoor study, especially on the backside of the machine. We can see the air filters, especially 5 micron fine filters or bag filters. So always plenum area is considered as to be a negative area. Why? Because the return air which comes from those rooms should be passes across that area round and round. So later, due to the suction of this fan, however, if a fan is working at the backside of the fan, you can feel some kind of suction. So due to this negative energy on the backside of this machine, the return air should be subjected along right hand side to the indoor unit itself. And yesterday I just mentioned about the fresh air connection, isn't it? So typically on the same plenum area walls, they will be provide some kind of wall openings. And sometimes this wall opening should be fitted with a fresh air duct or a fresh air duct damper will be there. So the purpose of this fresh air damper or a fresh air duct, especially in order to provide the atmospheric air to the plenum area itself, not to the air conditioning room. Instead of that, the fresh air will fill right inside the plenum area. Then you can see right here itself on the fresh air duct, you can see something called as to be bird screen or bird cowls and sand traps will be there. Okay, now, so what is the purpose of this bird screen cowl and sand traps? If it is a hollow structure, the birds, like especially this pigeon, started to uh, build their nest right inside the duct itself. So there should be a deficiency of atmospheric air will be happens. That's why we are providing some kind of mesh or a screen in order to prevent those birds from or hinder them to become its an habitat. Okay, that means simply we just hindering the birds to not to build their nest right inside the duct itself. Whereas in the outdoor unit, it should be still same as per the other non-centralized machines itself. That means the ODU should be placed a distance around like 25 to 30 feet itself. So that means you must need to place the indoor unit properly. And at the same time, the outdoor unit should be placed at a distance of 25 to 30 feet from the indoor unit itself. That means, in other words, it symbolically means the copper piping connection, especially suction line and liquid line. Okay. Then later you can see at the bottom of the machine, some kind of connections are made on the fall ceiling, which is called as to be access door or trapdoor connection. So what is the purpose of access door or trapdoor connection? The purpose of access door or trapdoor, suppose you got some problem right inside the machine, especially on the filter side, maybe even on the fan side itself. So we can't deliberately entirely crack the fall ceiling and look after onto the machine itself, isn't it? We can't do that in our normal conditions. So that's why we are providing some kind of access door or trapdoor connection. So whenever it's requires, you can simply open the trap door or that access door, and you can maintain or you can actually go for the maintenance process right on the machine itself. So it is much more simpler and much more reliable to use the area without breaking the fall ceiling frequently. Okay, now, so that is the concept of access door or trap doors. I think you must been seeing these trap doors, especially on some kind of movies, isn't it? So this is, so once again, guys, so in this scenario, the return air which comes from the room and the fresh air comes from the atmosphere should be both mixes up right inside the backside of the machine, and later it is again carried across the duct and should be rejected to those respective rooms itself. And again, the same cycle will take place. So this is how a ductable split air conditioner should work. All right. I hope it's clear. So this is the thing, guys. Actually, I told you now, the duct should be termed as to be a supplier side, which means the positive side, and the other connections, especially the returner side, should be act as a negative side itself. You can see this now. First of all, in each and every rooms, you will be having both supply terminals and return terminals. That is a mandatory thing. Just remember, guys, always the return air area should be greater than that of supply air area. So we can discuss these the parameters on the drafting side of or on the duct designing topic. Okay, now later it's about the drain pipe connection. So fair enough, we just proceeded about the major topics right on the DSA. So we know that, however, when the return air and the fresh air which having moisture content getting contacted with the evaporator coil, eventually there should be some kind of water droplet formation will be there, isn't it? That water droplet formation should be hindered. Sorry, yeah, pardon. That water droplets are connect collected with the help of a drain pan, and later it should be rejected with the help of some certain pipe, especially the pipe material should be CPVC. From nowadays they will be using CPVC pipelines, not PVC, CPVC, chlorinated polyvinyl chlorides. Okay, now, so among this one, the CPVC pipe should be used, and you know, the water should be stagnated right inside the pipeline for a long time. Maybe that means it caused some kind of flow imbalance right inside the pipe streams. So in order to rectify that problem, we need to provide some kind of slope for that specific pipelines, especially the drain pipelines. Generally, the slope angle is termed as something like 1:100, which means for each 100 millimeter distance of your pipeline, you need to provide 1 millimeter offset, which means a slope. Okay. Then once again, the other mandatory thing while providing a drain pipe connection is to attach a U-trap. So what is the purpose of a U-trap? Guys, as if the water started to flow across these pipelines, and eventually we studied that inside these machines, you will be having closed type centrifugal fans. So there is a high chance of uh, water which will be again reverted back into the drain pan itself due to the suction of the fan. And thereby, these water should be again sprayed across the or sprayed along with the supplier itself, which cause some humidity imbalance right inside the rooms. So that's why we need to must choose a U-trap. And these U-traps also having a certain distance, which means, the length of the U-trap is an important thing according to the fan suction. So that's how they design the U-traps, especially for different projects. Then I told you guys, typically these drain pipes should be also carried right inside the plenum area itself. Okay, now in a certain slope, and these drain pipes should be terminated on some kind of, we need to terminate the water now to the atmosphere, or even the termination point is called as to be drain point, the nearest drain point. So you can consider the nearest drain point as to be some kind of toilets, even kitchens, or like a kitchen outlets. So you can connect this drain pipe connection to right there itself, or even onto the balconies also. All right. Satisfactorily, we need to consider one more factor, which is the insulation of these pipelines, especially the copper pipelines as well as the drain pipe connections. These drain pipe the drain pipe which carries the water, but typically the water temperature, the water vapor right inside the return air and the fresh air eventually condensated when it is contacted with the evaporator coil, and these water droplets having a temperature should be around like 5 degrees, 6 degree, even 4 degrees Celsius, isn't it? The drain water should be comparatively colder than that of a room temperature water. So as if the water started to flow across this drain pipe connection, what will happen? Inside these pipelines are carried in the plenum area. In the same plenum area, you can see your return air, and this return air consists of moisture content now. So these moisture content again will be getting contacted on the pipe surface, and it can form some kind of water droplets on the surface of the entire pipe system. So in order to prevent that, you need to provide some kind of insulation on the drain pipe connections. So that is why we will be using a nitrile rubber foam insulation, especially for this drain pipe and even for the copper pipes itself. Okay, so is it clear? Clear, guys? Now we can study about the technical specification of a DSC, which is a ductable split AC. Generally, these kind of DSCs can be purchased from a capacity range of 3 ton to 25 ton. Okay, that is the normal capacity. And the other one, in the case of non-centralized systems, we studied that for 1 ton capacity, it can provide up to 300 to 350 CFM amount of air, isn't it? But whereas in the case of centralized machines, for 1 ton capacity, it can provide nearly 400 to 450 CFM. Then now we studied that inside this DS, especially in this centralized machines, we can see these duct connections. But there is a limitations to the duct connections also, which is the running length. That means from a single machine, what should be the probable max running length of a duct? Generally, for DSA, that means a ceiling suspended unit, the duct running length should be considered nearly like 60 feet to 100 feet distance. Okay, 60 feet to 100 feet connection. Then, as I mentioned before, the copper piping length is, which is still common, that is 25 to 30 feet itself. And generally, they will be using a rotary or scroll compressor. I told you guys, if it is a scroll, that means it is an inverter kind of AC. Okay, now. Then is electrical connection. So typically, the entire centralized machines are considered as to be three-phase biased machine itself. Why? Because these kind of machines are preferably used across like commercial regions, not for residential regions, isn't it? So that's why the electrical connection should be normally three-phase itself. So once again, okay, the purpose of U-trap is very simple, to prevent the water which flows again back into the machine due to the suction of the fan. So if you place this U-trap, this fan need more suction energy to uh, draw the water through this U connection, which is an impossible thing. That means that I told you guys, typically you need to properly design the U-trap distance according to the fan suction. Okay, then one more thing, when this water will be stagnated right inside the pipelines, eventually it creates some kind of algal formation right in the inner surface of the pipe. And it can cause a severe smell or a bad odor right inside the pipe stream. And it can simply comes again within the machine itself. So there should be a small foul smell right inside the supplier. Okay, so that's why we will be placing these kind of U-traps. Okay. Is it like NRV? Not like an NRV. NRV means non-return valve. U-trap is preferred. Actually, in the U-trap, some kind of trap seal will be there. Trap seal means some kind of effluent. That is the water. Okay, the water should be kept right on the bottom of this U connection itself. A little bit of water will be there. So this water will hinder the flow of any kind of odors right inside to the machines. Okay, now. At the same time, if you having a the fan need more energy to draw the water. But if it is straight pipeline, the fan can easily pull the water from the pipeline itself, isn't it? That is the purpose of installing U-traps across the system, especially on the drain line. Okay, now. Okay, Shamir, clear?
Sir, in this return air
Mm,
for duct supply,
mm.
the return air will be hot air or cold air from the room? Like
No,
it will
hot
be
air. Like,
hot air.
the
Okay.
starting cycles will be started up with hot air and humid
Oh,
air,
okay.
but
Okay.
after the same cold and dehumid air is supplied across the area, eventually it started to cool down that area and it will reaches its set point levels. So gradually the return air
Mm.
will become cold air itself after
Cold air
like
itself.
a 30
Okay.
minutes or 40 minutes, according to
Okay, sir.
temperature that you've been set it right on that area itself. So we can't predict in all
I-
time it should be hot air. Okay, now
Hot air.
that's it.
In those grills, there is no suction fan, but it will go to the ceiling, and
Which
from
one?
there
This one?
it will
Are
be
you asking about this one?
in this in those yeah, return grills. There
Exactly.
is no suction
Typically,
fan normally.
that's it. So it's like a convection, natural convection. Sorry, convection. That means we studied that hot substances will always go upwards, isn't it? And cold
Yes.
substances always go downwards. That is a simple idea.
Okay, sir.
And the working
Okay, sir.
principle
Okay.
is called as to be air stratification.
Due to
It's
pressure
depends.
or
It depends on the density, yeah. The
okay,
existing
sir.
air should
Okay.
be comparatively less density, isn't it? I
Mm.
told you, hot
Mm.
air always having high density. Pardon? Low
Okay,
density.
sir.
Low density. Hot air
Low
having
density.
low density. Cold air having high density. That's why we need more energy to push the air. அதுக்கு தான் நம்ம centrifugal blower fans use பண்றோம் instead of axial fan. Okay, now I told you that day itself. Remember?
Yes, yes, yes.
Okay,
Thank you, sir.
that's it. That's it.
So
So
when
typically
the
in the
return
return
air
air,
goes and through that suction fan, is there any suction fan for return air
no.
in the
Actually,
system?
it doesn't meant to be suction. As I mentioned before, at the back side of a fan should be always a suction. But I told you these kind
Yes.
of fans are high-end model fans, like a closed type centrifugal fan. So comparatively, the suction should be comparatively high, that of compared to a normal kind of fans. Okay, now that's why I'm
Okay.
saying. That's what I
Okay.
said. Like that, in these, especially in centralized machines, almost all
Okay.
whole fans are like the same thing itself. Like it's a closed type centrifugal fans itself.
Okay. So
Okay.
the return air any particular distance from the
No,
fan,
no, no,
they
nothing like that.
keep the
Nothing like that.
grills?
Nothing like that.
Nothing
I
like
will
that. Okay.
explain that
Okay.
one in the designing of
Design.
our,
Design. Okay.
yeah, duct designing. Okay, now there is no such things actually, but there is some kind of ratios are there that we can discuss later.
Okay.
Okay. Uh, then hot air, pardon, this return air, fresh air, whatever thing it is, air typically means it's not an idle thing. It should flow across wherever it wants, isn't it? That is the other idea. Okay. Now come again to this technical specification. So here, as in the case of centralized air conditioning systems, we can either use air-cooled condenser or water-cooled condensers. That means you can purchase water-cooled condensers separate from the manufacturers itself for that purpose. All right, clear? It's like a shell and tube. That's it. Then the average lifespan is around like 15 years. And first of all, it's a ceiling suspended unit, and you will be having a fresh air provision. And probably right inside these machines, it should be either electronic expansion valve or thermostatic thermostatic expansion valve. That's it. Then typically, if you are implementing a DSA, if you're having false ceiling, then it is much more aesthetical to look. Okay, now, or it will be more pleasing for the clients itself. If you don't having any false ceiling, it should looks like a mess. Why? Because the whole thing should be visible from the normal view itself. That's why. So is there any doubts, guys? Hello? I
Sir,
hope.
the fresh air is mandatory, no, for this duct
Yeah,
system.
exactly. Pressure is mandatory. Typically, fresh air
Why?
connections are made almost in this kind of commercial projects.
For any reason, sir? Like,
No. That's it. Told you na. In the initial, on the first class itself, I explained about the elements of air conditioning. On that class, I told you oxygen replenishment will be provided in an air conditioning process, isn't it? You need to freshen the air,
okay.
so we must need to provide oxygen. Okay,
Okay. Okay.
but
Okay.
in the case of high wall AC and tower AC and even window AC, we can't see this fresh air connections.
Okay.
Okay, now,
Okay.
but in
Okay.
even cassette and concealed AC, you can see this kind of fresh air connections, especially. Whatever, just remember this, Mark. If your machines are placed on ceilings, then you will be having a fresh air connection typically. Okay, that's it. So everyone, is it clear? Okay, Shanmuga, Shanmugaraj. Okay, clear?
Yeah, good, good.
Okay, fine. Avinash, are you getting this point, isn't it?
So, just one question. So, which
Yeah, go
cooling
on.
type is better, air-cooled condenser type or water-cooled condenser type
Hmm.
is?
Okay, what are you asking? I didn't get you, ma.
No, no. What I was asking is which type of condenser cooling is better? Is it air-cooled a
What do you
better
think?
one, or
What do you think?
I feel water-cooled?
Exactly, that's it. Water cooled is much better than air cooled. But typically air cooled is much more affordable than water cooled, isn't it? But in
Yeah.
some some areas, especially if you go for something like Middle Eastern countries, the ambient should be comparatively higher. So I told you that day itself, this R410A cannot be used as a air-cooled condenser when you having high ambience, isn't it? So in that scenarios, you can simply go for a water-cooled based condensers itself. So it's up to the refrigerant and it's up to the ambient itself. All right. But typically in
Okay.
India, we can simply go with an air-cooled condenser itself, where you can see the tonnage range. It's up to 25 ton itself. Okay, not saying beyond 100. So typically for DSA, ductable split AC connections, mostly the available capacity range should be in between of 3 to 25. That's it. That is a max spec. If it goes beyond 25, we will not install on the ceiling. It should be shifted to floor. That is the next mission that we are going to study, which is about ductable packaged AC, or it is called as to be vertical unit. Okay, what is it? It is a vertical unit. So it's something like a big brother of our tower AC. Okay, EV means electronic expansion valve. That's it, yeah, Shamir. Electronic expansion valve. That's it.
So one last doubt on fresh air. Will fresh air help in reducing the temperature and reducing the pressure in the evaporator coil? Will that help?
No.
It
I
will
told
not
you now.
help.
இவ்வளவுதான் ஷஃபீக் இவ்வளவுதான். ஃப்ரெஷ் ஏரோடைய இம்பார்ட்டன்ஸ் என்னன்னா, இப்போ நீங்க ரூம்ல ஒரு 15 பேர் இருக்கிறீங்க. நான் இங்க வெறும் ஹை வாலேசி மட்டும் தான் போட்டிருக்கிறேன்னா, ஜஸ்ட் யோசிச்சு பாருங்க, நீங்க 1 hour அதில் தாண்ட மாட்டீங்க. ஏன்னா உங்களுக்கு கொஞ்சம் கொஞ்சம் டிசினஸ் ஃபீல் ஆக ஆரம்பிக்கும். ஏன்னா ஃப்ரெஷ் ஏர் உங்களுக்கு அவுட் ஆயிடும். லைக் ஆக்சிஜன் மொத்தமா உங்களுக்கு அவுட் ஆயிடும். அது வெறும் இருக்கிற ஏரை மட்டும் தான் ரீப்ளேஸ் பண்ணிக்கிட்டே இருக்கும். கூல் பண்ணி அமைச்சுக்கிட்டே இருக்கும் லிட்டரலி. ஓகேங்களா? அதனாலதான் சொன்னேன், நீங்க ஒரு கொமர்ஷியல் ப்ராஜெக்ட் எடுக்கும் போது நிறைய ஆக்குபென்சி இருப்பாங்க. அந்த மாதிரி சினாரியோஸ்ல இந்த ஹைவால் மாதிரியான சிஸ்டம் வச்சா ஒரு பிரயோஜனம் இல்ல. அங்க ஆக்சிஜன் ரீப்ளேஸ்மெண்ட் நடக்காது. தென் ஆக்சிஜனுக்கும் நீங்க சொல்ற அந்த இவாபரேட்டர்ல இருக்கிற டெம்பரேச்சர் பிரஷருக்கும் ஒரு சம்பந்தம் கிடையாது. இட்ஸ் பியூர்லி O2. அதான் தேவை. அதுக்கு அட்மாஸ்பியரிக் ஏரை நம்ம யூஸ் பண்றோம். அட்மாஸ்பியரிக் ஏரோட டெம்பரேச்சரை குறைக்கிறதுக்காக தான் இவாபரேட்டர் காயில வச்சிருக்கிறோம். புரியுதா? நம்ம ரிட்டர்ன் ஏர் எப்படி வருதோ அதே மாதிரிதான் ஃப்ரெஷ் ஏரும். 2 பேருமே ஒரே ஸ்பெக் தான். உங்களுக்கு என்ன ரிட்டர்ன் ஏரை விட ஃப்ரெஷ் ஏர் கொஞ்சம் அதிக டெம்பரேச்சரா இருக்கும். ஏன்னா என்ன சொல்றது, ஆம்பியன்ட் டெம்பரேச்சர், உங்களோட அட்மாஸ்பியரிக் டெம்பரேச்சர், அது ரூம் டெம்பரேச்சரை விட அட்மாஸ்பியர் டெம்பரேச்சர் எப்படி இருந்தாலும் கொஞ்சம் அதிகமா தான் இருக்கும். ஓகேங்களா? பட் ஹவவர் அதுக்கும் நம்ம இவாபரேட்டர்ல இருக்கிற பிரஷருக்கும் ஒரு சம்பந்தம் இல்லை. ஏன்னா அந்த வேலை பாக்குறது யாரு? ரெஃப்ரிஜரேட். அப்படிதானே? That's it. Okay. So purely only the concept of allowing or என்ன சொல்றது, ஃப்ரெஷ் ஏரை உள்ள எடுக்கிறதுக்கு ஒரே ரீசன் ஆக்குபென்சி தான். அதனாலதான் நான் சொன்னேன், சென்ட்ரலைஸ்ட் டிசில நீங்க கவரேஜ் ஏரியா ரொம்ப அதிகமா இருக்கும். அதுக்கு மீனிங் என்ன? இட் ஷுட் பி ப்ராபபிலி யூஸ்டு ஃபார் கமர்ஷியல் பேஸ்டு ப்ராஜெக்ட்ஸ். ஸோ அங்கெல்லாம் நமக்கு என்ன தேவைப்படும்? ஹை ஃப்ரெஷ் ஏர்ஸ் தேவைப்படும். Sometimes, even though you are providing fresh air, you need to place a certain other kind of machines, especially called as to be TFA, treated fresh air systems. That is a different thing. So we can learn that thing in the upcoming sessions, whatever. All right. Okay.
Yeah.
Okay, fine.
Yeah.
So is there any doubts on this one? Okay. All right. Next of all, it's about our DPA, which is a ductable packaged AC or a vertical units. Typically, ductable packaged air conditioning system is a floor-mounted unit, and which is also a split kind of mechanism, which means you will be having an indoor unit and an outdoor unit, and the other connections are still same, which means the wired thermostat connection, even ducting also will be there. But here, in order to install this indoor unit, typically you need some kind of space. Why? Because I told you this is a floor-mounted unit. So, for example, if you are proposing this idea to your client and the client is asking, and you are demanding some kind of storage space, some kind of space for the installation of this indoor unit. If they are not providing, then you need to change your plans. But typically, these kind of DPAs are used for a huge project, which means a combined project. For example, if it's like a 40-ton project, they will use 4 DPAs or like 2 DPAs, 3 DPAs. Like, they split the tonnage. All right, that's the concept of this splitting mechanism according to the indoor unit concept. So for that one, we need certain rooms to install this indoor unit. Now we can study about the indoor unit study. This is the only machine which having the compressor right inside the indoor unit. All right, clear? In other words, for a DPA machine, the ODU which consists only condenser coils, not any kind of compressor right inside the ODU. Whereas in the case of indoor unit, you can see your compressor, evaporator coil, expansion valve. The entire thing should be arranged right inside the indoor unit itself. But in audio, you can see only your condenser coils itself. All right. Is it clear? Okay, now we can see the working of this one. So here you can see this portion is termed as to be the return air grill of DP emission. So this is an individual DP emission right here itself. And whole DP emissions having a top discharge mechanism. But you can see on the DSA, it is a side discharge mechanism. That means nothing but the air should be thrown in a sideways itself. But in the case of DPA, the air should be discharged in a top manner itself. Okay, so that's why we are using some kind of connections called as to be plenum box. That's we can learn right now itself. Now, just go after this picture. On the bottom side, you can see the compressor and a small insulation is provided. Why? Because on the other side, you can see your evaporator coil and the expansion valves, isn't it? And here also, we will be using a closed type centrifugal fan with a belt-driven connection. It will change according to the tonnage. Okay, now that means direct transmission and belt-driven transmission. Yeah, only possible upside. No, typically DPAs are manufactured like that way itself. It is meant to be a top discharge indoor unit. Okay, yeah, supply should be always through the top side itself. Now come again to this point, guys. So as I mentioned, in the indoor unit, you can see compressors. So this is the only one machine where the compressor is placed right inside the machine. So can anyone say what is the relevance, or sorry, what is the preference, or what is the importance that they install the compressor right inside the indoor unit? Tell me, guys, just think twice before answer. What should be the possible reason to place the compressor right inside the indoor unit? Hello? Come on. Any suggestions? Like Shanmugam, go on, any suggestions?
Faster cooling.
Solunga? Sorry?
Cooling should be faster, right? Like maybe if they have compressor.
Not like that.
Hmm.
So what should be else? Like think things once again. It's one package. No. Can reduce copper pipe length, but still you having copper pipe connections from compressor to condenser, which is placed outside itself. So there is nothing like that. Just think twice, ma. Yeah, as you said, you are nearly onto that point itself, like hot. You are very hot right now, like on this point. Ma'am, any suggestions? Are you there or not? Okay. Hello.
To reduce pressure balance control.
என்னம்மா புரியல?
Pressure to
Okay.
pressure difference come.
Okay, fine. So I will explain. So you are near to those points itself, but what will we studied that the normal copper piping connections are implemented, especially the suction or liquid line should be approx like 25 to 30 feet itself, isn't it? Am I right? So in normal conditions, the compressor should be placed on the outdoor units. Am I right? So just imagine, guys, if the compressor is on the ODU, it needs more suction to draw the refrigerant right from the evaporator, which makes the working more complicated. Am I right? Clear? நான் சொன்ன பாயிண்ட் புரிஞ்சுதா உங்களுக்கு? இங்க பாருங்க, நீங்க ஒரு திங்ஸ் நீங்க இப்போ இந்த பக்கம் இழுக்கிறீங்கன்னா அது எவ்வளவு தூரமா இருக்குதோ நீங்க கொடுக்குற ஃபோர்ஸ் ரொம்ப அதிகமா இருக்கும். அதே இது ரொம்ப பக்கத்துல இருந்துச்சுன்னா நீங்க லெஸ் அமௌண்ட் ஆஃப் எனர்ஜி கொடுத்தா போதும் அந்த செக்ஷனுக்கு. சொல்றது புரியுதா பாயிண்ட்? Hello, is the idea clear?
Yeah.
Fine. I mean, Shivaprakash and Avinash and other guys, clear? Okay. So ഇത്രയുള്ള മക്കളെ, അതായത് ഇപ്പം കംപ്രസർ ഒരുപാട് ദൂരെയാണെങ്കിൽ നിങ്ങൾ ആലോചിച്ച് നോക്കിയേ, ഈ കംപ്രസർ നിങ്ങളുടെ ഇൻഡോറിനകത്തിരിക്കുന്ന റെഫ്രിജറന്റ് ഇങ്ങോട്ട് എടുത്ത് എത്തിക്കണമെങ്കിൽ എന്തോരം എനർജി അത് പ്രൊഡ്യൂസ് ചെയ്യണം, ലൈക്ക് മീൻസ് എന്തോരം സക്ഷൻ അത് ക്രിയേറ്റ് ചെയ്യണം. അതേത് ആ ഇൻഡോറിനകത്ത് തന്നെയാണ് നിങ്ങളുടെ കംപ്രസർ എങ്കിലോ, തൊട്ടപ്പുറത്തിരിക്കുന്ന ഇവാപ്പറേറ്റർ, തൊട്ടപ്പുറത്തിരിക്കുന്ന കംപ്രസർ, രണ്ടിനും ഇടയ്ക്ക് ഒരു ഇൻസുലേഷൻ, സോ ഹീറ്റ് ട്രാൻസ്ഫർ നടക്കത്തില്ല. സിംബോളിക്കലി വർക്കിംഗ് കുറച്ചും കൂടി എളുപ്പമായി അല്ലേ. ഇനി കംപ്രസർ ചെയ്യുന്ന ഇനി പുറത്തോട്ടുള്ള ലൈനെ കുറിച്ച് നമുക്ക് ഒരു പേടിയും വേണ്ട. കാരണം എന്തുവാ, കണ്ടൻസർ എവിടെ ആയിക്കോട്ടെ, ഇനി കംപ്രസർ കഴിഞ്ഞിട്ട് ഇനി പുഷ് ചെയ്യുമ്പോൾ നല്ല പ്രഷറിലായിരിക്കും പോകുന്നുണ്ടാവുക. ഓക്കെ, സോ ഐ ഹോപ്പ് ദിസ് പോയിന്റ് ഈസ് ക്ലിയർ. ഓക്കെ, that's it guys. So this is the idea of a DPA indoor unit typically. So here the only element which comes inside the indoor unit should be a compressor. Okay, the other connections are still same. And next of all, it's about the ODU. So as I mentioned before, inside the DPA ODU, you can't see any kind of compressors. The only element should be an axial fan with a fan motor and the condenser coils. All right. So this is how it should be looks like a side discharge assembly with a single fan or double fan. Then in the prior sessions, we studied that the copper pipe connection, which should be taken from evaporator to the compressor, should be termed as suction line, isn't it? And from condenser to the expansion valve, or even from ODU to IDU, is termed as to be liquid line. Why? Because it's going in a liquid manner or a liquid characteristic, a liquid type, isn't it? Or a liquid phase. That's why it is called as to be liquid line. So here, am I need any suction line? An external suction line is required for this connection. Hello? Tell me guys, am I need any external suction line connection? No, isn't it? Why? Because it's already lined inbuilt-inly right inside the machine. We don't need any external copper piping for that suction line. But we need another connection which connects the compressor to condenser, isn't it? So what should be possibly that line called as? Any idea? What should be that line called as? What is the specification of the outletting refrigerant from a compressor? You said it has to be like a superheated vapor, isn't it? Am I right? It's a superheated vapor. That's why those lines, especially on DPA, the copper pipe connection which connects from a compressor to condenser, that means IDU to ODU, that is compressor to condenser, should be termed as hot gas line. Why? Because it's a high pressure and high temperature in a gaseous state itself. Okay, now that's why it is termed as to be hot gas line. Then the other connection is still same, this liquid line itself. All right, from condenser coil to expansion valve. Now you can see. So, all right. So let's talk into the connection of this entire DPA with the duct system. We studied that this machine is a top discharge type. That means it will provide supply air in a top discharge manner itself, isn't it? So as of the cold air supplied in a top discharge manner, in order to accommodate this one, we need a small connection piece called as to be plenum box. The purpose of plenum box is not only to accommodate the air, but also to split the air according to the direction wherever you want. Okay. So I will show the picture. You can see right here itself. Now, this is the common collecting duct. And these are the typical DPA connections. DPA 1, 2, 3, 4. And these whole connections are terminated right on to the common collecting duct right here itself. And from this collecting duct, you can take the ducting in either left, right, backside, or wherever you want. Okay, now, clear? So that is the purpose of a plenum box. Then the other connections are still same. That means, the duct connections will be there, air terminals will be there, especially supply air terminal and return air terminal. And regarding with the same scenario from a DSA, we studied that the hot air should be rejected maybe to the plenum area, isn't it? These DPAs are placed right inside a room, isn't it? I told you initially DPA requires a room for the installation, and it should be typically connected like this way itself. So these DPA rooms doesn't have any kind of false ceiling connection, and it always should be open In other words, the entire return air should be terminated right into the DPA room itself. All right. Is it clear, guys? Once again, you can see right here itself, this DPA room doesn't have any false ceiling. In other words, that means the entire air connections or the return air should be terminated right into the DPA room. No, why? Because it doesn't have any false ceiling, so it should be freely open. At the same time, on this DPA rooms, they will be provided the fresh air damper. That means the fresh air duct. So the atmospheric air should enter right inside to the DPA room, and thereby the return air and the fresh air should be properly mixes up on the backside of this machine. Backside, which means the return air grill or the return air side. On the specific side, on the inside of the structure, you can see the air filters will be there. And again, the evaporator, sorry, this air, the both return air and fresh air should be again getting contacted with the evaporator coil and again pumped back to the same supply line itself. So this is how the DPA should operate. Then once again, while placing this DPA, we need to consider some important points. The first one is about shock absorber. So shock absorber is not a mandatory thing, but the other basic thing that we can do is about initially for the placing of this DPA, you need to provide some kind of, you need to raise the floor like a 3 mm or a 5 mm concrete slab, something like this. You can see right here itself now. These each and every DPAs are placed on top of a concrete slab, and these on top of to this concrete slab, you need to provide a rubber pad, and on top of this rubber pad, then only you need to install your machines. So what is the relevance of this thing? You know, inside these machines, you can see this fan, especially a closed type fan. So it will literally create a lot of vibrations, isn't it? So in order to damp the vibrations, that's why we've been providing this kind of floor rising along with the rubber pad connection. In other words, you know, if you placed these machine directly on the floor, the noises or the vibrations can be resonated on the floor below. So the persons on the bottom floor can hear the noise which comes out from those specific machine. Okay, now that's why we need something like this. And once again, these DPA room should be entirely insulated with acoustic insulation. So what do you mean by acoustic insulation? Acoustic insulation, which prefers nothing but, you know, it's a small insulation that should be provided on the walls in order to eliminate the noise comes out from the room. Why? Because, you know, there are a lot of DPAs are working, isn't it? So it can create more noise right in the room. So these noises can be heard right outside to those rooms, and it should be a bit disturbance to the nearby cabins or nearby areas, isn't it? That's why we need wall acoustic insulation right inside and DPA room. Okay. So this is the concept. Then other connections are still same. That means the drain pipe connection. So this is, you can see right here itself now. This is how these drain pipe connections are done for a DPA. On this picture, you can see the copper pipes are railed like this way. You can see this now by providing a small channel support. On top of that, they are implemented this copper pipe connection. And this is how these electrical cable connections are provided. A proper cable, sorry, a ladder type cable tray is provided on the ground. And the electrical cables are laid across this cable tray, and the individual connections are made. Okay, now. So that's it. That's all about this one itself. Now we can see about the technical specification. So typically, the cooling capacity range of this DPA machines should be ranges from 310 to 25 ton. Then once again, 1 ton is equal to 400 CF. Then while discussing in DSA, I told you the maximum duct running length should be around like 60 to 100 feet itself. That's for a ceiling suspended unit. So typically for a floor mounted machine, the main advantage of that machine is their duct running length. Why? Because a normal DPA can connect up to 100 to 150 feet of duct single-handedly from a single DPA itself. Okay, now, then the other connections, the The other technical specifications are same, which means the copper piping length. That means compressor to condenser and the condenser to indoor unit. And the compressor should be rotary or scroll, and it should be using a three-phase current electrical connection. And the condenser cooling should be either air cooled or water cooled. Then the important major things are DPA room is mandatory and DPA room wall insulation is also mandatory. And for that, a DPA room, you need to bare-handedly provide the fresh air connections also. Then only a proper fresh air and return air mix-up will happen. All right. So is the idea is clear? Okay. So this is all about this one itself. Okay now. Is the DPA machine is clear? Hello? Hello. All good guys. Okay. All good. Shanmugam, Purinjada, Shanmugamana, Shiva
Yeah.
Prakash, Manu,
Yes.
we get this points. Good. Okay, I hope all goes. DPA room fully insulated or raised floor room. No, both need to do. Like, that is not only for the mission, but also for the rooms. These connections, it's for the mission. But the wall insulation for the noise which comes out from the mission, from the continuous working of the machine, gradually a noise will be appears or a noise will be happens right inside the room. In order to eliminate that noise without escaping from that room, we need an mandatory acoustic insulation on the walls of that DPA room. Okay, clear? Okay, Le? Fine. Okay. So next of all, we are going to discuss a different kind of mission, which is called RTU, which is termed as to be rooftop unit. So first of all, a rooftop unit should be a little bit similar to your window AC itself. That means it is a single box installation, and this machine also requires ducting. Then the advantage is no copper pipe is required. That means if it is a single box, that means no indoor or no indoor or no outdoor, isn't it? That hello, is my point is clear? Simply here we don't need any external copper pipe connections to connect the compressor, condenser, expansion oil, evaporator coil, whatever, because it should be already lined up when you'll be purchasing right from the manufacturers itself. So no need to worry about that stuff. Then once again, no cablings are required. That means, the complicated cablings from indoor to ODU, that's not required. Directly, you need a simple power supply. That's it. Then once again, RTU is a floor mounted unit, and these RTUs are placed on top of the roof. That's why it is mentioned as to be a floor mounted. Then once again, for this also, we need to provide a small floor rising like this way. You can see this now. They provided some kind of concretes, like a small concrete raising. And on top of this concrete raising, they provided these kind of rooftop units. Now let's discuss about the components right inside this rooftop units. We can see this is a typical arrangement of RTU. So the concept is very simple, guys. One side should be connected with the compressor, condenser, that's it. And the other side should be consist of expansion valve, evaporator, blower fans. All right. Then the middle portion is termed as to be the mixing box or a side portion, whatever you can call. But in this picture, it is mentioned on the middle, isn't it? Right now, you can see these kind of condenser arrangement is termed as to be V-type arrangement. And here, it is not a side discharge axial fan. These whole connections of axial fans are termed as a top discharge type. Okay, what is this type? Top discharge axial fan type. So the heat should be absorbed from the atmosphere and thereby it should be rejected in a top-wise manner itself. Okay, guys, good to go. Willfully, next you can see this air filter connection and evaporator coil. And this is the closed type centrifugal fans. And it should be connected with the supply fan. That means, the RTU will be, pardon, the RTU will have a mouth opening, and these mouth openings should be connected with the supply fan itself. Now, discussing this one, which much more explanation. You can see this now. This is meant to be the mixing chamber. What is it? The mixing box or mixing chamber. That's why they provided the air filter. And this is the evaporator coil. And you can see the fan is throwing the air directly on this way itself. And the other side, you will be having a thermal partition. And this is the compressor and condenser coil. And this is a top discharge axial fan type. We can see the expansion valve right here itself, isn't it? And this is strainer. So this is how it works. Normally, we studied that for each and every machines, supply duct should be important, which means you can see supply ducts in each and every machines. Then, as in the case of return air, it should be gradually flows across the plenum area, then to the backside of the machine, or either to the DPA rooms, isn't it? This is how we just exaggerated these things. But whereas in the case of RTU, even though if the return air comes across the plenum area, there will not any use of this return air. Why? Because our machine is placed right on the roof itself. For that one, we need a connection to take out this return air and to terminate right inside the mixing box. That's why, especially in the case of RTU, we need to provide a mandatory return air duct. That means here you can see two type of ducts. The first one should be supply air duct and the other one should be the return air duct. The purpose of supply air duct should to deliver the cold air to the room, and the purpose of return air duct to deliver the hot and humid air to the mixing box. So that's how the return air and fresh air will mix us up right inside this area, and it is again reverted back to the supply duct itself. So this is how the cycle goes off. Normally, RTUs are preferred for something like a 4-story building, 3-story building, 5-story buildings. That's how it works generally. All right. Is it clear? So the main advantage of this machine is you will like a single box installation. No external connections are required. No cablings. And the other things are a mandatory return air duct is important, and it must need to connect it with the mixing box of this RTU right here itself. Here, the cooling capacity ranges from 5 ton to 40 ton. Okay, now, and the flow rate relation again 1 ton equal to 400 CFM, and the duct running length is around like 100 feet, both for supply and return. So that means you can simply connect the supply duct and return duct in an adjacent manner itself, and you can take out these both ducts to that respective RTU itself. Then here we can see the important points. Return side need any suction fan? No, actually it will work its own. The end, it should be much more similar. Here I told you now. In here, these return air terminals are connected with this return duct. Okay, now. Likewise, here also, no? Here these are the air terminals, isn't it? Likewise, for this return air also, you can have some kind of return air terminals. So the same fan will draw the air here. That means I told you, however, a suction will be there. So might thinking like that, is these fan have enough capacity to draw the air from those each and every rooms? Yeah, obviously it can. And I told you, due to the natural convection process, the hot air deliberately goes upwards, isn't it? That is the other idea. Okay, Shamir, manslayo. Okay, now. Okay. All right. Next, you can see this now. This is a terrace mounted machine. No exposed copper piping. And the important point is mixing box for fresh air and return air. That's it. So this is the basic 3 centralized machines that we studied, which are DSA, GPA, and RTU. Next of all, we are going to discuss about chillers. So today I'm going to just give a small intro about the chillers. Not much. Basically, chillers are classified into two different manners according to the compressor classification and according to condenser classification. So if you are using a scroll type compressor, then the chiller should be called as scroll chiller. If you are using screw compressor, then it should be called as a screw chiller. If you are using a centrifugal compressor, then you can call it as to be a centrifugal chiller. But normally chillers are not much famed for their compressor based classification. Instead of that, they are generally famed for their condenser type. So typically two type of condenser types are there, which is air-cooled chillers and water-cooled chillers. All right. So on the next upcoming sessions, we will be discussing about the connections of this air-cooled chiller and water-cooled chiller. And especially we will discuss about the heat exchangers, cooling towers, and this kind of stuffs. All right. I hope it's enough for today. So is there any respective doubts on this topic? No, isn't it? എല്ലാവർക്കും മനസ്സിലായോ? പുരിഞ്ചതാ എല്ലാവർക്കും?
Yes, sir.
So, one question, sir. So, if you take an office site, right, like 3-storied or 4-storied building, RTU மட்டும் இருக்குமா இல்ல combination of RTU and DPA எல்லாமே இருக்குமா?
எங்க
If you take any office space, right, like 3 stories or 4-storied building.
Exactly. இப்போ நீங்க cold storage எல்லாம் போறீங்கன்னா அது preferably RTO எல்லாம் இல்ல. Cold storageக்கு இப்போ அதுக்கும் இருக்கும் tonnage ranges. So according to the tonnage, that means the heat capacity that you need to remove, isn't it? அப்ப அதை பேஸ் பண்ணி தான் மிஷின்ஸை வைப்பாங்க அவங்க. சிம்பாலிஃபிக்கா இந்த கோல்ட் ரூம்ஸ் எல்லாமே என்னவா தான் இருக்கும்? சில்லர் தான். கோல்ட் ரூம்ஸ்ல டிபிக்கலி உங்களுக்கு சில்லர்ஸ் இருக்கும். ஏர் கூலா இருந்தாலும் வாட்டர் கூலா இருந்தாலும் பரவாயில்ல. உங்க இப்போ உங்களுக்கு ஒரு சீரிஸ் ஆஃப் ரூம்ஸ் இருக்கு.
ஏர் கண்டிஷனிங்.
சீரிஸ் ஆஃப் ரூம்ஸ். ஓகே. அதாவது நான் சொல்றது புரியுதா உங்களுக்கு? இப்போ நிறைய கேபின்ஸ் இருக்கு. கோல்ட் ரூம் கண்டிஷன்ல கீப் பண்ண வேண்டிய நிறைய கேபின்ஸ் இருக்குதுன்னா யூ ஷுட் கோ ஃபார் ஏ சில்லர் அண்ட் ஏஹெச்யூ. அப்போ இந்த ஒவ்வொரு கேபின்ஸ்ல நீங்க ஒரு எஃப்சியூ வச்சுக்கிட்டு என்ன பண்ணிக்கலாம்? உங்களுக்கு எஸ்பெஷலி நான் சொன்ன மாதிரியான நெகட்டிவ் லெவல்ஸ்ல யூஸ் பண்ணக்கூடிய அல்ட்ரா லோ டெம்பரேச்சர் லைக் R500 அந்த மாதிரி ரெஃப்ரிஜரன்ஸ் யூஸ் பண்ணுவாங்க. ஓகேங்களா? சொல்ற கான்செப்ட் உங்களுக்கு புரியுதா?
ஓகே.
பட் ஆர்டிஓ எல்லாம் பாத்தீங்கன்னா ஒரு 4 மாடி 2 மாடி பில்டிங் எல்லாம் ஓகே தான் அது. தென் 10 மாடி பில்டிங் எல்லாம் ஆர்டிஓ வைக்க மாட்டாங்க. புரியுதா? தென் eventually இந்த எஃபிஷியன்சி வைஸ் பாத்தீங்கன்னா ஆர்டிஓ இஸ் நாட் மச் பெட்டர் than compared to DSA or DPA. ஓகேனா? புரியுதா உங்களுக்கு? ஓகே. That's it. Then what is Shamir asking? Shamir, up to here all cold compressor, up to chiller, all kind of air conditioner rotary. And yeah, exactly. This DPA, DSA, even for RTU, the compressors are still scroll or rotary vane. Okay, now, especially rotary vane is preferred for low-end models that like below 5 ton. High-end models are always scroll itself. That means from 5 ton to 25 ton, 40 ton, you'll be using a scroll compressor itself. Then more than 50 ton, 100 ton, you need to go for a screw compressor. Okay, now, clear or no? Okay. So that's it, guys. So I think it's enough for today. We can wind up the session. If you're facing any kind of doubts, just let me know in the WhatsApp itself, so I can assist with you. Fine. Hope you're good. Okay, now.
Thanks.
Okay, fine, guys. You can leave. Have a great day ahead. Bye.
Thank you, sir.